Hello, it's Dr. Mears, and today we are going to be learning about antiderivatives and integrals. First, let's learn about the antiderivative. The antiderivative undoes the derivative. So think about as if we worked backwards from the derivative function to the original function. I do give you a rule, but I think going through an example and then going back to the rule and saying this is what we did here might be a little bit better. So let's go to the example first. We're going to need to find the antiderivative of each function. So number one, f of x equals 1 times x to the 8. And the reason why I said 1 times x to the 8 is because this one in our rule right here is going to be the numerator. So whatever coefficient is in front is going to end up being that numerator. That's why in this rule, when we go back to our original function, and that's why it's a capital F, because capital F means our original function from our derivative, the coefficient in front is going to be in the numerator. So let's go to our original function, capital F equals the coefficient 1 divided by, now we need to do n plus 1. This exponent is n, so we're going to do 8 plus 1 times x, and make sure it's a big X. I don't want the x to be in the denominator. I want it to be a big X because this is really times this right here. And then we're going to do to the exponent of n plus 1, and so that's going to be 8 plus 1. And then we're going to do plus c, because there may be some number, some constant, like 2 or 4 or minus 7 or even plus 0 is a constant, but we don't know what that number is from the original, so we always have to put a plus c. Then we just clean it up. F of x equals 1, 8 plus 1 is 9, x the 9th plus c, and we're done. And that's what this rule says, that it's the 1 divided by the coefficient in front of x, the exponent plus 1 times x, raise the exponent plus 1 plus c, which is a constant. Okay, number 2. F of x equals 1 over x to the third. So first we have to get that x to the third out of the denominator. So we're going to make this x to the negative 3. Then we could take the derivative, which means we're going to go back to the antiderivative. Sorry, you can take the antiderivative, which means going back to the original function. So this is going to be 1 over, and it's 1 because this does still have a coefficient of 1. That 1 actually is right there. And we're going to do negative 3 plus 1. X, the negative 3 plus 1. And if you notice, these are always plus 1s, so you can always remember it. F of x equals 1 over negative 2, x the negative 2, and we can clean it up even further. Because this is a negative exponent here, we could do f of x equals, I'm going to put that negative in front, negative 1 over 2x squared. And you can even put the 1 like in the middle, right here will look much better. This negative could be in the denominator or the numerator, anywhere you want it. I just put it out in front. And so that's it. There you have it. Let's try the third example. So here we have f of x equals the 5th root of x to the third. We want to take the root symbol out. So remember, it's going to be x to the exponent divided by the root. So it's going to be f of x equals x to the 3/5. That's the exponent. Now we can take the derivative. F of x equals, this is a 1 over 3/5 plus 1, x to the 3/5 plus 1. Then we could do a little math. This is going to be 1 over 8/5 times x to the 8/5. 3/5 plus 1 is 8/5. I'm going to clean it up even more because I don't like this 1 divided by a fraction. So when you see that, you just flip that fraction in the denominator. That's really 5 over 8, x to the 8 over 5. And there you have it. All right, let's keep going. Let's look at what's called indefinite integrals. And indefinite integrals is bringing in a symbol. The expression with this little wavy symbol here is called the indefinite integral. The f of x dx, the antiderivative of f with respect to x, or the integral of f with respect to x. So instead of writing like I did in the previous one, instead of writing just fx equals, we're now putting a symbol to it. We're saying, okay, we need to take the antiderivative of x to the 7th because this was the derivative. The derivative is x to the 7th, and I want you to take the antiderivative. And so this is that same rule. It's going to be the antiderivative plus that constant. But now this symbol represents, please take the antiderivative, which is also called the indefinite integral. That's another name. So what this is going to equal is going to be 1 over, this is a 1 in front, 7 plus 1, x the 7 plus 1. And so the indefinite integral of f with respect to x, or x to the 7th, dx equals 1 over 8 times x to the 8. And then don't forget your plus c. A lot of people forget that plus c. We still need that constant there. We're not sure if there was a number being added on to the original. Okay, next, what happens if there's not a variable? So we need to take the integral of 6 du. So if there's not a variable there, what you do is you look at the d and then you look at the variable next, du. So all you're going to do here is just do 6u. So this is the variable that they tell you to use. And that's it. That's the answer, is just 6u. So when you don't have a variable there, when you just have a constant, you're multiplying it times the variable that it gave you. 6 du is 6u, and that's it. You keep it. Okay, and number 3, we need to take the integral of 4t cubed plus 6t squared plus 3t, which is of dt. And so what it wants you to do here is just do one at a time. So we're just going to look at that 4t cubed. So now, because we have a number in front of t, this 4, that is now going to go in the numerator. Usually we had a 1. That was the number in the numerator. But since we have a coefficient, that stays in the numerator. And then we have to do the exponent plus 1, t to the exponent plus 1. Plus 6 in the numerator, exponent 2 plus 1, t raised to the 2 plus 1. Plus 3 does not have a variable, so it's just going to be 3t. We're going to clean it up a little bit. So this is going to be 4 over 4. 3 plus 1 is 4. T to the 4th, 6 over 3t squared plus 3t. Don't forget plus c. Don't forget plus c. I almost did. Shame on me. All right, so 4 divided by 4 is 1. So this is just t to the 4th plus 2t squared. I just divided 6 by 3 plus 3t plus c. And so what we did here was we took the antiderivative. So that's this symbol right here. So when you see that symbol, it wants you to take the antiderivative of what follows it. And that's it. And so we need the antiderivative in order to use it for the fundamental theorem of calculus. Now, I can do a lesson where I get in depth about the fundamental theorem of calculus. This lesson is actually how to do it. So when we use the fundamental theorem of calculus, what we want to do is we want to find an answer for two given numbers, b and a. So if you notice in this equation, 3 to 0. And what we need to do here is first we're going to take the antiderivative of what's inside, x minus 2. Then we're going to be substituting those numbers in and subtracting. That's the fundamental theorem of calculus, and this is how to do it. So let's do it. So first I'm going to do a set of brackets, and I'm going to show you why after, but let's just take the derivative of what's inside. So we're going to take the derivative of each one of these separately. So the derivative of x is going to be 1 over 1 plus 1. Now remember, these are all 1s because the 1s like to hide. X to the 1 plus 1. Minus 2 doesn't have a variable, so 2x. I'm going to close these, and then on the outside, I'm going to put a 3 and a 0 because those are the numbers that were given to us. And I'm going to need to substitute these numbers in after I clean this up a little bit. So 1 over 2, 1 plus 1 is 2, x squared minus 2x. I'm going to need to first substitute 3 in and then substitute 0 in. And I don't want my lights to go out. So I'm going to turn them on. The lights were going out, so I had to run. Okay. So I need to substitute 3, and that's what this says. Put b into the original function, and then put a into the original function and subtract them. What does that look like? So it's going to be 1/2 times 3 squared minus 2 times 3, brackets, minus 1/2. So I did the 3. Now I need to use 0. 0 squared minus 2 times 0. And then I did the 0. It's always the top one inserted first and then that bottom one. Okay, let's do some math. So this is going to be 9 over 2 minus 6 minus, this actually is 0 minus 0, so that drops out. So I'm just at 9 minus 2, which equals negative 3 over 2. And so we get to that answer. So we find between 3 and 0, we have a negative 3 over 2. That's how to use the fundamental theorem of calculus. Okay, explaining it, I can make another video, but this is how to use it. And the last one here, so we go back. Now, we cannot turn this into, I know it's in the denominator, but we can't turn it into t to the negative 1. And the reason for that is the rule. And I'm trying to find my paper. Here it is. So we cannot have that exponent. N cannot be -1. So here's the thing. We cannot use this. What I see here is 1 over t. When we take the antiderivative, ln t, when we take the antiderivative, we go back to the natural log of t. So this is ln t. So this derivative, if you watch my videos, derivative with other functions, you're going to see to take the derivative of ln t, it's going to be 1 over t, or the natural log of t is 1 over t. So you can't use this one. You could use it if this was -2 or -3, that's fine, but it can't be -1. That is a rule that you will find in your formula booklet. So it's one of those things where you're like, this feels different. Okay, what do we do here? So we are going to have the brackets, and we're going to do natural log of t, and we're going to go from 6 to 2. So we're going to put the natural log of 6 minus the natural log of 2, so substitute these in and subtract them. Now, when you subtract them, if you want to bring them down to 1 natural log, we've learned this last year, which was it's hard to remember over the course of the year, but when you're using logs and natural logs and you have subtraction, what you're really going to do to the numbers is you're going to divide them. So that's the rule. That's what happens. So if you want to go from natural log of 6 minus natural log of 2, it's going to be the natural log of 3. And you're done. So I brought in a derivative, an antiderivative of another function because our rule said we cannot have -1 as the exponent. You could have any other negative number, but it's not 1. So it's one of those things you have to remember. We took the antiderivative, we substituted the 6 and the 2. We had to divide because that's the rule. When you have subtraction of 2 natural logs, you divide their numbers, and then we get the natural log of 3. This has been a lot. You have learned antiderivatives, indefinite integrals, right into how to do the fundamental theorem of calculus. I hope it helped.